All right, we are on to acid base, which I believe will be the final video recording. Now I have to keep in mind the limited time because there's a lot more I could cover, a lot more that I can go into, but I hope I did a good job of distilling down uh, at the very least like the important concepts and breaking those down for you guys. Highly, highly, highly recommend any link I put in, but especially Dirty USMLE links. And I'd recommend actually that if you can watch this immediately after watching mine, so you get the exposure from two different learning sites and you get them back to back. Okay, so when you think acid base, think two ions. Acidity is primarily determined by hydrogen ion, and alkalinity, I don't know, basicity is determined mainly by the bicarb ion. And this equation, bicarb buffer equation, is coming to play a role again. You'll see this like so many times. But if you understand this, and I used to understand this equation a lot better, and then like write it out, these compensation, the primary disturbance and the compensations will make sense. For instance, if we look at Y, so Y does okay, let's think respiratory acidosis. So why does you can't blow off the excess CO2. So why does CO2 accumulation cause a acidosis? For increasing this side of the equation a bunch, there has to be some response ramping up, so to speak, of these carbonic anhydrase to push this equation to the right as a response to the increase in CO2. And then what you get is an increase in hydrogen ions in the blood, and you also get an increase in this, but that's tightly regulated by the kidneys, I guess. I don't know, that might not be the best example. I should really review that actually, bicarb buffer equation. So if you understand it really well, you can understand like why the compensation shifts a certain direction. But obviously I don't understand it as good as I thought I did. Hopefully that was right. Okay, anyway. Okay, so CO2 produced by cellular respiration. And that makes sense, right? Remember the external respiration and internal respiration. Internal respiration, the tissues receive oxygen and in response give CO2 to the bloodstream. It's then taken on the venous side back to the heart and then to the lungs, where it's blown off by breathing, exhaled. In addition, CO2 can combine with water to form carbonic acid. That's what this is called, carbonic acid. I can never remember what it's called. Okay, so what's going on in the kidney, this carbonic acid is converted to hydrogen ions and bicarb. The hydrogen is excreted, so we get rid of it. And that's how it handles hydrogen. And then the bicarb is reabsorbed back into the bloodstream. Let's see. I think you guys went over this. Even if you didn't, we can talk a little bit about it now. So titratable acids, you'll see this again. Dr. Rausch will talk about this. So the way that the excretion of acid is performed is it has to be combined with some type of buffer. And it's usually a phosphate buffer. That's kind of a buzzword, phosphate buffers. or combined with ammonia to form ammonium ion. And then in that form, and in only that form, can it be peed out, basically. And this is a good thing because we definitely want a way to get rid of nitrogenous waste products like ammonium. So a good way is to combine it with hydrogen. Okay, so that's what happens normally, right? And what happens in acidosis, too much, as you can imagine from the name, too much acid in the body. And what that means is low pH, right? Thanks to, God, who are those guys? Oh, Henderson Hasselbalch. Thanks to Hendy and Hassel, we have an inverse relationship because they decided that they should make it logarithmic. So if we have a buildup, an increase in hydrogen ions, that means a decrease in the pH, which doesn't make any sense, but everybody should know it by now, hopefully. So if the primary cause is in the lungs, so primary respiratory, it's due to some form of, usually like hypoventilation, or some prevention of CO2 being exhaled. So you're not blowing off enough in the lungs. Now, if it's primary metabolic cause, either the kidneys are not excreting enough to be peed out, or there is increased formation of hydrogen ions. Because if you can't excrete, some of it might be reabsorbed into the blood, or there can be increased formation or ingestion, and that can be anywhere. That's just not just in the kidneys. In the case of alkalosis, it is going to be due to, remember, it's all about bicarb usually, or a decrease in PCO2. Because just think inversely. Sorry, I'm kind of winding down now. The lungs are blowing off too much, so some type of hyperventilation. Too much CO2 is being exhaled. That results in a decrease in the CO2 in the blood. And that's what would happen if it was a primary respiratory alkalosis. Now, excreted too much. Metabolic acid. Oh yeah, in cases of diuretics or GI losses, it'll be a primary metabolic cause. Sorry, I should have looked at these slides before. These are Dr. Harp's slides. Most commonly results. Okay, this is referring to, I believe, in the cases of vomiting, you're losing hydrogen ions, which are acidic, and that can cause alkalosis. Okay, so this is going to be the most important takeaway. When you're interpreting a question, and you'll have a ton of these questions, you may have already had some, you have to be able to nail down immediately whether it's respiratory alkalosis, respiratory acidosis, metabolic acidosis, or metabolic alkalosis. And because of that, you got to memorize the normal ranges. And this is a quick and easy way of remembering the normal values, but the ranges are good to be aware of too. Okay, so normal pH range can be like 7.35 to 7.45. You may see a tighter range like 7.38 to 7.42. The PCO2 normal range is, I believe, I'm just going off of memory, so I hope this is all right. I think it is. We'll see. 38 to 42. Or wait, no, sorry. I think it's 35 to 45. Normal range of PCO2. PO2, like normal range, 95 to 100. And normal range of bicarb in the blood is 22 to 26. So memorize those ranges. And if not, just memorize the normal values. Okay, so the first and easiest thing to do is look at the pH. So it's acidemic, high alkalemic. Then, and the order is important to this too, as you'll see in my next slide, look at the CO2, a measure of how well the patient is ventilating. So if the PCO2 is decreased, that means you're blowing off too much CO2. So we have a case of hyperventilation, like anxiety or pain. If it's increased, that means the patient is retaining CO2, so they're hypoventilating. Respiratory depression would be an example. And remember what kinds of overdoses can cause those. Benzos and opiates. And I think an alcohol, I believe, is also a respiratory depressant. Put a question mark. Okay, next. Yeah, I think that's right. Next, look at the bicarb concentration. And that tests how well the patient is functioning to maintain normal pH. So when it comes to so you have a disturbance, you have a primary cause that leads to some form of compensation. And if you just remember this concept, you can kind of figure it out because the primary cause is going to be like complete opposite of the compensation. Okay, so if the primary cause is respiratory acidosis, the compensation will be basically a metabolic alkalosis. So everything is reversed. The systems are reversed, right? It's respiratory versus kidney, and then the acidity or alkalinity is reversed. So everything's reversed. Hopefully that makes sense. This is a great table. I recommend you probably focus on this because this lecture sucks. So this is my shortcut if you don't want to have to understand it. You should understand it, hopefully. If not, you'll understand it later. But for now, if you want a little shortcut, look at the direction of the arrows. So look at pH and PCO2. If both the arrows are going down, it's a metabolic acidosis. Now this shortcut doesn't work all the time, okay? Just be aware of that. But it works most of the time. You have the arrows going the same direction. The primary cause is going to be metabolic. So in the case of metabolic acidosis, the primary disturbance, the first thing that happens is some decrease in bicarb. This is metabolic cause. So could be like GI, usually it's renal. So let's say if you had a kidney situation where the kidney is being really bad at bicarb excretion. That means more bicarb will be building up in the blood. I'm sorry. If the kidney is really bad, let's say at bicarb reabsorption, then that means less bicarb than usual will be in the blood. You'll have a decrease in bicarb. So let me repeat that. If the kidney is really bad at bicarb reabsorption, okay, which usually it's good at, but in the proximal convoluted tubule, then that means you'll have a decrease in bicarb. That would be the primary cause. And remember when I said the compensation is like exact reverse. So in compensation, the respiratory system will start to increase the breathing because you want to blow off a lot of CO2. And so that's the mechanism that you actually see on the lab values, the decrease in PCO2. Okay, so the primary disturbance is here. Metabolic alkalosis, again, the arrows go the same way because it's metabolic. This would be a situation like I was talking about earlier. Like if the kidneys are really bad at bicarb excretion. Okay, that means more bicarb will be reabsorbed. That means more bicarb will build up in the blood and cause an alkalosis type of state. In response, because the compensation is complete opposite, primary cause is metabolic alkalosis. You have the compensation is something that would cause a respiratory acidosis. Okay, you want it to be opposite because you want to bring those pH levels back down to normal. So primary disturbance, metabolic alkalosis. The compensation is something that would cause a respiratory acidosis. Does that make sense? So you have a compensation of hypoventilation, and that is the reason for the lab value you see, increased PCO2. Okay, now the arrows go the opposite directions. The primary cause is respiratory, and this makes sense. Okay, if the primary disturbance is an increase in PCO2, that means there's some type of respiratory depression going on. You're retaining CO2. In response, the kidney will ramp up its bicarb reabsorption, and increased bicarb means you are making the blood more alkaline in order to compensate for the acidosis. If the primary cause is respiratory alkalosis, that means there's some case of hyperventilation. You're blowing off too much CO2, and that means there's not enough CO2 in the blood. In response, the kidney will decrease its reabsorption of bicarb, and that means there is less bicarb in the blood means less of something that is alkaline, which means a shifting of the pH to a more acidic state. Okay, that does it.